The National Electrical Code, or NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It's part of the National Fire Code series published by the National Fire Protection Association, or NFPA. While the NEC is not itself a law, it is commonly adopted by states and municipalities in an effort to standardize their enforcement of safe electrical practices. In some cases, the NEC is amended with local requirements. The NEC is updated every 3 years. The purpose of the NEC is to provide a comprehensive set of guidelines and requirements for electrical installations addressing a wide range of topics. Firstly, general electrical safety. Secondly, wiring methods and materials. Thirdly, overcurrent protection. Fourthly, grounding and bonding. Fifthly, equipment installation. And sixthly, special occupancies. The NEC covers various types of electrical systems, including power distribution, lighting, appliance circuits, and control systems. It also addresses the installation of equipment in different types of occupancies, such as residential, commercial, and industrial buildings. Some key articles and chapters within the NEC include Article 90, which covers the purpose and scope of the code, Article 100, which provides definitions of terms used throughout the code, Chapter 2, which focuses on wiring and protection, Chapter 3, which covers wiring methods and materials, Chapter 4, which deals with equipment for general use, Chapter 5, which addresses special occupancies, and Chapter 6, which covers special equipment. The NEC uses a system of tables to provide specific requirements for conductor sizing, overcurrent protection, and other aspects of electrical installations. For example, Table 310.15b16 is used to determine the allowable ampacities of insulated conductors. The NEC is enforced by local electrical inspectors who review electrical plans and inspect installations to ensure compliance with the code. Failure to comply with the NEC can result in fines, project delays, and safety hazards. The NEC is an essential resource for electricians, electrical engineers, inspectors, and anyone involved in the design, installation, and maintenance of electrical systems. Regular updates and revisions ensure that the code remains current with the latest technologies and safety practices. To effectively navigate the National Electrical Code, it's helpful to understand its structure and organization. The NEC is divided into chapters, articles, parts, and sections. Chapters are broad categories. Articles cover specific subjects within a chapter. Parts break down articles into more focused topics, and sections provide detailed requirements. To find information, firstly use the table of contents, secondly use the index, and thirdly become familiar with common articles. Some key articles to be aware of include Article 110, which covers requirements for electrical installations, Article 210, which covers branch circuits, Article 215, which covers feeders, Article 220, which covers branch circuit, feeder, and service calculations, Article 230, which covers services, Article 250, which covers grounding and bonding, Article 300, which covers wiring methods, Article 310, which covers conductors for general wiring, Article 400, which covers flexible cords and cables, Article 430, which covers motors, motor circuits, and controllers, Article 450, which covers transformers, Article 500 through 516, which covers hazardous locations, Article 600, which covers electric signs and outline lighting, Article 625, which covers electric vehicle charging systems, Article 680, which covers swimming pools, fountains, and similar installations, Article 690, which covers solar photovoltaic systems, Article 700, which covers emergency systems, Article 701, which covers legally required standby systems, Article 702, which covers optional standby systems, Article 705, which covers interconnected electric power production sources, and Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. When using the NEC, firstly consult the definitions in Article 100 to ensure that terms are interpreted correctly. Secondly, determine the voltage, amperage, and other electrical characteristics of the system. Thirdly, identify the applicable articles and sections based on the type of installation. Fourthly, use the tables provided in the NEC to determine conductor sizes, overcurrent protection requirements, and other parameters. Fifthly, pay attention to any notes or exceptions that may apply to specific situations. Sixthly, ensure that all work is performed in accordance with the NEC and any applicable local codes. And seventhly, have the installation inspected by a qualified electrical inspector to verify compliance. It is important to stay updated with the latest edition of the NEC and to participate in continuing education courses to maintain a thorough understanding of its requirements. The National Electrical Code provides minimum safety standards. Electrical installations should always be performed by qualified individuals who are knowledgeable about the NEC and other applicable codes and standards. Remember to prioritize safety in all electrical work. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow lockout/tagout procedures. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician or electrical engineer. Electrical safety is everyone's responsibility. By following the NEC and other safety guidelines, you can help prevent electrical shocks, fires, and other hazards. The NEC is a living document that is constantly evolving to reflect changes in technology and safety practices. It is essential to stay informed about these changes and to adapt your work accordingly. One effective way to stay up to date with the NEC is to subscribe to newsletters and publications from organizations such as the NFPA and the International Association of Electrical Inspectors, or IE. These resources often provide insights into code changes, interpretations, and best practices. Another valuable resource is attending industry conferences and training sessions. These events offer opportunities to learn from experts, network with other professionals, and gain hands-on experience with new technologies. Many manufacturers of electrical equipment also offer training programs on their products and their proper installation in accordance with the NEC. When working on electrical projects, it is important to maintain accurate records of all work performed. This documentation can be helpful for future maintenance and troubleshooting, as well as for demonstrating compliance with the NEC and other regulations. Records should include details such as conductor sizes, overcurrent protection ratings, grounding and bonding connections, and equipment specifications. It is also a good practice to take photographs of installations before they are concealed behind walls or ceilings. These photos can provide valuable visual references during future work. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. The NEC provides guidelines for these activities in Article 110. During inspections, look for signs of damage, overheating, or corrosion. Test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or of size, to verify that they are functioning properly. Tighten any loose connections and replace any worn or damaged components. Remember that electrical work can be dangerous if not performed correctly. Always prioritize safety and consult with qualified professionals when needed. By staying informed, following best practices, and maintaining a commitment to safety, you can help ensure that electrical systems are installed and maintained in accordance with the National Electrical Code and other applicable standards. Always use the proper tools and equipment for the job. Use insulated tools when working on or near energized circuits. Wear appropriate personal protective equipment, such as safety glasses and gloves. Follow lockout/tagout procedures to prevent accidental energization of circuits. Never work alone on electrical projects. Have someone nearby who can assist you in case of an emergency. Be aware of your surroundings and potential hazards. Keep work areas clean and free of obstructions. Avoid distractions and focus on the task at hand. Never take shortcuts or compromise on safety. If you are unsure about any aspect of an electrical installation, consult with a qualified electrician or electrical engineer. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help prevent electrical shocks, fires, and other hazards. The NEC also addresses specific requirements for different types of equipment and installations. For example, Article 430 covers motors, motor circuits, and controllers. This article provides detailed guidance on selecting the correct overcurrent protection for motors, sizing conductors, and installing motor control equipment. Article 450 covers transformers. This article addresses topics such as transformer overcurrent protection, grounding, and ventilation. Article 680 covers swimming pools, fountains, and similar installations. This article provides specific requirements for bonding, grounding, and GFCI protection in these locations. Article 690 covers solar photovoltaic, or PV, systems. This article addresses topics such as conductor sizing, overcurrent protection, and disconnect requirements for solar PV systems. The NEC also includes requirements for emergency systems, legally required standby systems, and optional standby systems. These systems are designed to provide power during outages and other emergencies. The NEC specifies the types of loads that must be connected to these systems, as well as the requirements for their installation and maintenance. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, fire codes, and energy codes. It is important to be familiar with all applicable codes and standards before starting any electrical project. The NEC is not a substitute for good engineering judgment. There may be situations where the NEC provides minimum requirements, but a more robust design is necessary to ensure safety and reliability. Always consider the specific conditions of the installation and use your professional judgment to make informed decisions. The NEC is a valuable resource for anyone involved in the design, installation, and maintenance of electrical systems. By understanding the NEC and following its requirements, you can help ensure the safety and reliability of electrical installations. Always prioritize safety and consult with qualified professionals when needed.